Ready, guys?
Yeah.
All right, everybody, welcome to the last session, at least in this room for today. So thanks for joining us late in the day. Today, the topic is Design, Build, and Test an OCP AI Cloud Network with Industry-Leading Performance. My name is Matt Roman. I'm joined by J.M. Hands and Mark Austin, and they'll introduce themselves a little bit more here in a second. So let's just jump right into it. Actually, before we jump right into it, let me just a little bit, a bit more about myself. So again, Matt Roman. I'm from Celestica. If you're not familiar with Celestica, Celestica is a technology company. We're headquartered in Toronto, Canada. We have a number of different lines of businesses, but for the purposes of why we're here, we are a leading designer and manufacturer of IT equipment for hyperscalers, for OEMs, and we bring a full line of products to market through the channel and to direct end users as Celestica branded products in a turnkey solution. So that's a little bit about Celestica. Mark, do you want to talk about yourself and Hedgehog and what you guys do?
Sure, yeah. I'm Mark Austin. I'm CEO and co-founder of Hedgehog. We are open source AI network software.
Yeah, John Michael Hands, CEO of FarmGPU. We're a new rising neocloud, and I'm going to be co-chairing the neocloud work group in OCP.
Awesome. Okay, so that was the introduction. I guess we'll talk about sort of three phases: design, test, and the most exciting part, the performance at the end. So that'll be the wrap up. I'll talk just the sort of Celestica contribution that's in the solution that we'll talk in more detail about. Really revolves around a high performance Ethernet switch. It's called the DS5000. It's a 51 terabit switch platform, 64 port interfaces, and it's running the Sonic network operating system. So that's the main part of the Celestica portion of the solution that we'll talk about here today.
And that's an OCP design, right?
That is an OCP inspired design. Thank you so much for mentioning that.
And so I'm the software guy up here. So yeah, Hedgehog really was it was born at OCP. So my first OCP Global Summit was 2021. I was still working at Cisco at the time. That's where I kind of was exposed to this world of open computing and came up with the idea for Hedgehog. We announced the company in 2022 here at OCP Global Summit. And we built the product around an OCP project. It's now part of the Linux Foundation, but it's Sonic. And what we do generally is build a software appliance around Sonic, and we're part of the Cloud Native Computing Foundation with that project.
Cool. Thanks, Mark. All right, JM, you want to jump in here?
Yeah. You're going to hand me this?
Yeah.
Yeah, so we thought it would be fun to kind of go through our first cluster build. I know all the rage here is building gigawatt clusters, but we started with a reasonable network for a 32-node cluster, and after we kind of decided on the design, where we landed with the OCP switches, I'll be honest, it was we picked Ethernet because of cost. It was 50% cheaper than the reference architecture, and so that and our budget for this cluster, that was what we had. So ideally in the future, we learned a ton of lessons during this first cluster build, and we're going to be open sourcing and contributing a bunch of stuff in the OCP white paper that kind of describes some of the challenges we went through, and again to fix it in the next design so that we can go a lot faster. One of the things we learned is, ideally you want to do, having the networking gear there first before the cluster gets there. You do not want extremely expensive B200s or B300s sitting idle. That's extremely challenging. When we got the B200 servers, we had our team rack them, install them in the data center, and we installed the 10 gig Ethernet. And we actually had a bunch of challenges during bring up that were nothing network related. This is just bugs with NVIDIA. Ubuntu is required for one of our customers, for their platform, and there was a bug with Blackwell at the time. We did this in July with Ubuntu that in the older kernel, this CUDA doesn't work. You have to have a software workaround and a kernel patch. And so we figured that out in a couple days. So 2 days into the cluster build, we had already passed full burn-in tests, and the NVIDIA diagnostic tests on all the B200s. So we're like, yes, ready. Now we just have to plug everything in. That was a 17-day process. When it turns out, when you know the optics, now I understand why the hyperscalers have like such robust sourcing things on the optics, because the optics that we were trying to order that were compatible with the switch or had been tested in the validation and compatibility lab, well, those were a 6-month lead time. Well, we're not going to have our B200 sit idle for 6 months, so that wasn't an option. We just had to order the ones that were around, and so we found a critical bug with the Broadcom and Celestica and optic. It was just with this optic, and it was some initialization thing. This ended up taking like a couple weeks to grind through to debug, and there was all kinds of other problems that was around the build that made debugging this specific issue extremely challenging. But it was one where the optic didn't initialize if you had broken out the ports before you inserted it, and you had to hard reboot the switch to get it to come back up. So this was extremely challenging to find, and it took Hedgehog, Celestica, Broadcom, our optics guy, everybody on the phone together for like multiple days to go figure out like, okay, where's the bug? Why is it happening? So we wrote, during this cluster build, we wrote a ton of Ansible playbooks on really basic networking stuff, LLDP, mapping different MAC addresses to Ethernet device names using MLX config. There was a ton of stuff that didn't work out of the box with the NVIDIA configuration. Oh, they shipped the Connect X7s to us, and they're in InfiniBand mode. Okay, we have to turn them to Ethernet mode, and we rebooted. You're supposed to be able to reboot the NIC. Oh, there's a bug where it just reboots the server on our Supermicro. Great. So oh, it turns out there's a bug on the Supermicro BIOS that it hangs the BIOS once out of every 20 boots. It just hangs the BIOS indefinitely for like until a technician hard power cycles the system. So it's like you're in the middle of debugging on a call with 25 engineers and the system hangs, and you're like, just terrifying stuff. Optics. So it's very easy to think, oh, you just plug in the MPO cables. It's easy. One speck of dust can cause extreme havoc on the entire cluster. So again, now we learned our lesson of like why they're professional networking teams to go do all this fiber install. We said, oh, this is easy. It's only the first starting build was like 6 servers. We're like, oh, we can just cable this in an afternoon. It's gonna be easy. No, there was a couple mistakes made, with optics. Like, okay, the optics on the bottom of the switch, it's anybody who's done networking forever knows, like, of course, like the lanes are reversed because the optics upside down on the bottom of the switch. Well, a technician doing this for the first time doesn't know that. They're like, okay, this is port 1 and that's port 2. And so they're like, I'm reading the sheet. It says plug into port 1 right here. And so we spent, so the total time to live between plugging in the cluster and going live with RunPod, and I'll talk about the product that we ended up launching this with is called RunPod Instant Clusters, which you can rent the entire cluster with one click through Docker and run MPI or Slurm on top of Docker, which gets bare metal performance, but you can spin up the cluster and spin it down in a few seconds. So this is like nothing else that the market has. And there was a lot of learnings on the RDMA side and getting all that stuff working, but there was a very specific way that these that the Ethernet had to be set up in subnets and such that this would work. But 90% of the time to build this cluster was spent on networking and debugging network issues.
Yeah. And I should say also, being the network software guy here, right? Like our job is to make this whole thing run a lot faster, right? Our goal should be from the time everything's plugged in and cabled. Right, for a 64 GPU cluster, you should be up and running in an afternoon, right? So to do that, what we do is we run a test lab. It's here in the Valley, and we get equipment from our partners like Celestica, and we do continuous automated testing on the software that runs on the switch and our controller and all the configuration on it. And we do that every day, and we debug it every day. So the lesson learned, the macro lesson learned on this, is that the network is about a lot more than just a switch, right? There's a lot of other components in between, and we really need to be testing all of that, right? So if we're talking about optics, we need to have a hardware compatibility list that's not just switches, but switches plus optics. And when we talk about zero-touch provisioning, it needs to be more than just the software, installing, booting, and configuring. It also needs to be the actual installation services from a qualified service provider.
Yeah, and it's easy to say, oh, just buy the qualified optic or buy this. And most of the time, that's the correct answer. But if that solution is 5 to 10 times more expensive, then that's not the right answer.
or if it's unavailable.
Yeah, or if it's unavailable. So after we built the cluster, and we're starting to do some rentals. So you heard the semi-analysis is doing their Cluster Max V2, and we gave them our B200 cluster for a month to do this nickel benchmarking and to try to get this feature live on our new RunPod Instant clusters. And we also learned a lot about running nickel, and this was our first time doing a cluster level benchmark with nickel. And it sounds easy. You just grab it from, download the code from GitHub, compile it in CUDA, and run it. Okay, it's a lot trickier than that. There's the minimum node count to run nickel, appropriately is 4 nodes. You can't run it with 2 because there's some tricks with the all reduce. You can't run it with 1 because then the all reduce just happens locally to the NVLink switches. So you need 4 nodes to properly test this. So what happens during the all reduce is, on the B200s, they have NVLink switches that talk at 1.8 terabytes a second between all the GPUs. That's the first phase of the all reduce, and then the message size gets transmitted to every GPU to communicate to all the other GPUs in the cluster and across different message sizes. If you have one thing wrong, in this list, you will reduce the performance by 50%. So one of the things, for instance, like, oh, you have to disable IOMMU and PCIe ACS, because if you don't disable PCIe ACS, then every single IO hits the CPU first and doesn't go to the GPU direct to the NIC out to the cluster.
There's a magic config.
Yeah. 50% performance reduction with one change. Well, it turns off when you turn off IOMMU, now you can't support KVM VMs. So it's like now you choose either Kubernetes and Slurm, and this is going to be a training cluster, or you're going to rent this out with VMs in a different config. So these are pretty serious trade-offs that are not obvious. The cabling, we talked a lot about the mistakes and the optics that, I said I know a lot more about optics than I'd like to. I'm an SSD guy. I started as an SSD guy at Intel and did a lot of form factor work in EDSFF with OCP. Man, optics are like 100 times more confusing than SSD form factors. So that was a challenging learning curve. During this testing, semi-analysis was extremely helpful, and they weren't being jerks. They're like, hey, I see you probably don't have this thing enabled. You guys should do this. We grinded through a bunch of different BIOS and kernel settings and tweaks, different drivers. I mentioned just getting a ConnectX-7 to connect to a Sonic switch is not easy. We actually had to learn that you have to force the link speed to the required link speed. You had to turn auto negotiation off. You had to enable the breakout in the right order or have nothing with link. Just getting the things to link is like an act of God. But once we have the recipe, now it's repeatable. And this was what we were mentioning. We're going to open source all this in kind of a white paper describing how all this stuff is set up, so that the next time we build a cluster, the next time somebody else builds a cluster using OCP Sonic, is a lot smoother.
Yeah, and that drives the release for Hedgehog, right? So, we install software on Celestica switches. We run controllers on some commodity hardware. The thing we need to add now is host-based networking, right? So that we're testing layer 1 connectivity before we move forward with anything else. We're making sure that we've got the the right version of all the drivers, kernel, et cetera, and that we're configuring the NIC so that it's got that magic configuration out of the box on the ZTP, and that we're also including a nickel test package so that you don't have to just go figure that out, right? You should be able to test and verify the performance of the network. We provide already, open telemetry out of the box, but we need to be able to be driving the test flows on that as well.
Yeah. The kernel modules, the drivers, just a lot of not obvious things with NVIDIA. We love NVIDIA, but their documentation sometimes is not so great. Digging through some of these docs to figure out what the right version of driver should be, and the different compatibility between them. I mentioned the things on the NIC. Nickel, it's very easy to just accidentally run Nickel with MPI wrong, where it does the all reduce on each. It'll appear that you're doing it with all 4 IPs on the different servers, but you're actually just doing an all reduce on the single server, and this is communicating with itself. If you don't see the ranks go all the way from 0 to 32, then you're actually not running a proper Nickel run, and the GPUs are not communicating with each other. The switch, obviously turning on RDMA, turning on the hashing with the Q pairs and all the other performance tuning things. So that's stuff that they'll be able to put in the package next time to be these are the automatic tuning that you want to do for a switch on Sonic if you're running Nickel that will get you the best performance.
Yep.
So
Lots of lessons learned.
Lots of lessons learned. Now, my head of engineering that was running all this nickel tests, he hadn't touched nickel before diving into this, and he's definitely not a networking guy. He's a Linux kernel guy. And we went from not knowing how to run nickel to we think we have the best RDMA Ethernet performance. Well, currently, I mentioned the Cluster Max, V2 is coming out. Probably, I know when it's coming out, but I can't say soon. But this was from the very first Cluster Max report that SemiAnalysis wrote. They had a nice little graph in there about some of the different message sizes that they test. When you run nickel, you get a nice long log, and it has all these different message sizes. This is just a couple of them that they picked out that they think are useful. But you want to see the scaling. I mentioned first the all reduce happens within the GPU node. So on a B200, you have NVLink, V5. So it's going to be twice as fast as an H100 or an H200 on the NVLink switch side. That helps. The amount of cluster size also dictates your performance. So it may not be exactly apples to apples. We'll see if we can test another 4-node cluster with some different parameters, but just to show you how to do the comparison, if you have more GPUs in the cluster, then the smaller message sizes will be impacted. Now, on the high-end side, on the bus bandwidth, you want to be as close to the bus bandwidth as possible. So each of these B200 HGX have 8 ConnectX-7 400 gig NICs, so 400 gigs total, between 400 gigabytes a second total of bandwidth between each GPU node on Ethernet. And you can see we are able to get like 392 gigabytes per second, so almost near perfect scaling on our RDMA and Ethernet. And much better than a lot of the H100 clusters that are in production today, or that are larger scale that were tested in that first round. So this was exciting.
The net story here, right? It was a little bit of a horror show getting this thing up and running.
Yeah.
Right, but once we got up and running, is it fair to say the performance exceeded expectations? Yeah. It did mine anyway.
We're excited, yeah. I mean, if you think about the performance that we're showing here versus some of the InfiniBand clusters from the previous gen XDR, well, it's not like a small price difference. It's like a 3x price difference. And are you able to charge your customers 30 cents more an hour for the GPU instance to have InfiniBand in the training? No, the answer is usually no. So we're happy with Ethernet. We're excited to keep building out. We're going to be planning our B300 cluster right now, and this will be the first time we plug in 800 gig ConnectX-8 into a DS5000 and a Sonic switch. Again, nobody's done this before at scale. We're gonna be pathfinding and trying to. We may be one of the first customers to get the B300 cluster up with this Ethernet fabric. So yeah, it's gonna be. I'm sure.
It's gonna be fun.
I'm sure we're gonna learn a lot in this next round and share it with the OCP community. So.
Yeah. Yeah. So OCP call to action. What JM just described is really it's an OCP reference architecture for AI training as the primary workload. So what we're going to collectively contribute to the Open Compute project is this AI training reference architecture. So it will consist of Hedgehog open source software. It'll consist of Sonic, which is an existing OCP project. It'll consist of Celestica DS5000 switches, and it'll consist of OCP optical transceivers. And what you should get out of all of this is, okay, here's a training cluster out of the box, right? Here's the bill of materials I need. Here's the software that tests, installs, configures everything so that you're not spending 17 days or more bringing it up. That it's an afternoon. If you want more information on Celestica, you've got a booth here, right?
We do. B2, big presence, a lot of technical experts ready to engage with you guys.
Yeah, and if you want more information on Hedgehog, it's all open source, right? So you can go to GitHub, look up Git Hedgehog, that's the repo. The docs are there as well, and you can download the software for free and try it out whenever you want. I think that's it.
Awesome.
Some questions, maybe?
Yeah. Any questions?
There must be some.
We're between
we have
us and happy hour.
full room. No questions. I'm surprised. Somebody be brave.
Industry-leading performance. Competitively priced.
For now, yeah. We got to stay on top of it. Yeah.
All right.
Enough
thanks,
said.
folks.
Thanks, everyone.